In the world of AI, things move at light speed. But what happens when we have to start questioning the very foundations we just finished building?
For a while now, there's been one magic acronym for just about every problem with large language models: RAG, right? Retrieval-Augmented Generation. It was supposed to be the fix, the patch that made everything better. But what if that fix is already broken? What if our go-to solution is actually built on a really shaky foundation? Okay, let's get into it.
So, to really get why we're even asking this question, we've got to rewind a bit. Let's go back to the original problem RAG was actually built to solve in the first place.
All right, so LLMs are pretty incredible. We all know that. But they've got some major weaknesses. For one, they can hallucinate, which is a nice way of saying they just make stuff up. Two, their knowledge is basically frozen in time, right? It's stuck on whatever data set they were trained on. And three, they just don't have that deep niche expertise you need for something like, say, medicine or high-level finance. Now, sure, you could retrain them, but that is crazy expensive. So RAG came along as this brilliant, elegant, and way cheaper solution to all of that.
And just like that, this idea pretty much became the industry standard. I mean, it's the blueprint for thousands of AI apps out there today. It was supposed to be the hero of our story, but you know how it goes. Every hero has a fatal flaw.
So what exactly is RAG? Well, the simplest way to think about it is like giving an LLM an open book test. Instead of just trying to remember everything from its training, the model gets to look up the answer in a trusted external source before it says anything. This is what grounds the answer in actual facts, and it's what's supposed to make it more accurate, more current, and just more trustworthy.
And this diagram really lays it all out. You ask a question, and that kicks off a search in some external database. The system finds the most relevant bits of info, combines them with your original question, and then hands that whole package over to the LLM to generate a final, fact-checked answer. Seems pretty perfect, right? Flawless, even.
But how does that search part actually work under the hood? Well, it's basically a 5-step dance. Step 1, you take your documents and chop them up into small, bite-sized chunks. Step 2, each one of those chunks gets converted into a numerical vector. Think of it like a mathematical fingerprint that captures its meaning. 3, all these vectors get stored in a special vector database. 4, when you ask your question also gets turned into a vector, and the database finds the chunks with the most similar fingerprints. And finally, step 5, those retrieved chunks are tacked onto the prompt for the LLM. Believe it or not, this 5-step pipeline is the engine driving most of the AIX we use today.
Okay, but here's where the story takes a turn. This really elegant solution, this blueprint we've all been using, it turns out it has some deep, hidden flaws. And I mean, cracks in the very foundation that are getting harder and harder to ignore.
I love this quote from a recent AAAI paper because it hits the nail on the head. It says, "Vector RAG is like a consultant who's only read the executive summaries. You know the type, fluent, super convincing, but they critically lack the deep, verifiable connections between the facts. Because it shreds all these documents into disconnected little pieces, it loses the context. It reads the bullet points, but it has no idea what the full report actually says."
And this really gets to the core of the issue. Similarity is not the same thing as relevance. Vector search is all about finding what sounds like the answer, based on how close 2 points are in some abstract mathematical space. But what we really need is what is the answer, based on actual structure and relationships. So one method gives you this messy semantic scrapbook full of random text snippets. The other, well, it gives you a neural map where all the knowledge is actually connected.
And the second big problem is it's even sneakier, because it's completely silent. We see the AI giving us a bad answer, and our first instinct is to blame the model. But one analysis put it perfectly: this isn't an AI problem at all. It's an infrastructure problem. The bad answers are just the symptom. The real failure is happening way back in that retrieval step, long before the LLM even gets involved.
And this table here breaks down some of those silent failures. You've got index drift, which happens when your source data gets updated but the vector index doesn't, so you get stale, irrelevant results. Then there's ingestion duplicates, where the same document gets processed over and over, creating noise that just messes up the similarity scores. And maybe the worst one, embedding mismatch, where the index and the queries were made with different models. That basically means your whole search is broken because they're speaking totally different languages. Again, these aren't exotic AI issues. They're basic, classic infrastructure problems.
Okay, so if the standard blueprint is flawed in theory and it fails in practice, what's the alternative?
Well, this brings us to the big reveal, a totally new way of thinking about retrieval. And this new approach is called Vectorless RAG. The name really tells you everything you need to know. It completely gets rid of embeddings and vector databases. Poof, gone. Instead of just searching for semantic similarity, it actually uses the LLM's own powerful reasoning to navigate the real structure of the documents. Kind of like how a human would read and understand it. This side-by-side really tells the whole story. On the left, you've got the old way, just a simple linear search through a pile of disconnected text chunks. But on the right, you see the new approach. The LLM first looks at the query and figures out the key concepts. Then it navigates a structured knowledge graph, pulling out not just isolated facts, but the critical relationships that connect them. It's a massive shift from just searching to actual reasoning. And the results, honestly, they are staggering. Check this out. On a tough benchmark for financial questions called Finance Bench, one of these new vectorless RAG systems hit 98.7% accuracy. Now get this, traditional vector RAG systems, they barely scrape by at around 50% on that same test. This isn't just a little bit better, it's a complete game changer. So how does this actually work? Well, it's all built on something called a knowledge graph, like you see here. Instead of just storing those random chunks of text, a knowledge graph stores entities, things like diet or type 2 diabetes. And, this is the crucial part, it also stores the explicit relationships that connect them, like treats or is a risk factor for. This is what creates that neural map we mentioned earlier. It gives the AI a real framework it can use to reason. So this whole evolution from a basic search engine to a true reasoning engine, it's really a fundamental shift in how we should be thinking about AI memory. So, back to our big question, is RAG actually dead? Well, no, not exactly. But it is definitely evolving. The future probably isn't about throwing out vector search entirely. It's about building smarter, hybrid RAG systems that can intelligently combine the best of both worlds. So what does that look like? Think of it this way. Vector search is amazing for what we call high recall. It's like using a huge flashlight in a dark room. You'll find all the possible clues, even if some aren't useful. Now, graph traversal, that's all about high precision. It's like having a compass that points you directly to the treasure in a maze. A truly smart hybrid system uses both. It knows when to use the flashlight and when to use the compass, creating a truly intelligent navigation system for all that knowledge. So we've gone on quite a journey here, right? From the initial promise of RAG to uncovering its hidden flaws, and now to seeing its next big evolution. What we're really watching is AI's memory transforming from that messy, semantic scrapbook into something that looks a lot more like a reasoning brain. And that leaves us with one last really exciting question to think about. Once that transformation is complete, what impossible questions will we finally be able to ask?